Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, I am going to talk about symmetry in chemistry. So symmetry is common phenomenon in the world around us. It is difficult to overestimate the importance of symmetry in many aspects of science, not only chemistry. You can see that these two pictures, and you see the natural symmetry. You can see here how much symmetry it is. Marvelous. Now friends, here you can see the symmetry. Here you can see in architecture, in facial symmetry, you can see. So mirror image relationship indicate facial symmetry. No mirror image relationship. So friends, symmetry is a very important aspect of chemistry, and an understanding of it is important in spectroscopy, crystallography, and molecular orbital calculations. An example of this is seen in comparing the two molecules below. You can see here, A is more symmetrical than B. A is more symmetrical than B. So what? So symmetry operations. What is symmetry operation? A rearrangement of a body after which it appears unchanged. Rearrangement of a body after which it appears unchanged. A symmetry operation moves molecules about an axis, a point, or a plane to a position distinguishable. Look at the molecules. Water. So, if you just label the hydrogens, then what will happen? So, you have some tools with your hand. The symmetry element considered in group theory in relations to molecules are axis of rotations. Axis of rotation is represented by capital C small n. N 1, 2, 3, 4, 5, 6 like that. And mirror planes represented by sigma. The two most important symmetry elements. Now another center of symmetry, it is known as I, improper rotations, Sn, and identity E. One need to be able to identify the symmetry present in molecules. You can see here. So proper axis of rotations. First you applied Cn. A rotation about this axis by an angle 360 divided by n leaves the molecule in an indistinguishable configuration. Such as is indistinguishable word. This word is important. If you understand this word, then Cn you can easily understand. So indistinguishable configuration, such axis is called n-fold proper axis of rotations. N-fold proper axis of rotation. For example, in water C2 axis is there. Why C2 axis is there? Look at the here pictorial diagram. If you rotate C2, C2 means here n is equal to 2. N is equal to 2 means you are dividing 360 into 2, you are getting 180. So this axis present in water molecule. So in ammonia, C3 axis is present. C3, 3 indicate 360 divided by 3. So this axis present in ammonia. Now friend, there should be more than one C2 axis. In a molecule, there is possibility of many C2 axis where you can do the rotations. So example is BF3, there is a 3 C2 and 1 C3 axis. Now you can apply your common sense. If your molecule is like that, so if your axis pass through the center, means B, you will get the C3 rotations. And if you pass through the along the bond of BF, you will get the C2. So in such cases, there are one principal axis. If you have many C2, automatically you have the one main axis and then another axis. So principal axis exists with the high value of N. So this molecule contains C3 and C2, so principal axis becomes C3. If more than one axis of high order are there, then axis passing through the maximum number of atoms. For example, in BF3, C3 is principal axis. Now friend, you can see. Now some geometrical image you can see here. C4 axis, C3 axis, C2 axis and C6 axis. So plane of symmetry sigma. A molecule possesses a plane of symmetry if reflection through the plane leaves molecule unchanged. So there are many plane, horizontal plane, vertical plane, dihedral plane. So vertical plane is that the plane of symmetry is parallel to the principal axis. Horizontal plane if plane of symmetry is perpendicular to the principal axis. And dihedral plane if vertical plane bisect the angles between the two C2 axes. For example, in water there is 2 sigma V, no sigma H, no sigma T, because this contains vertical plane along the C2 axis. So red is molecular plane. Now friend, plane of symmetry in BF3, 1 sigma H horizontal plane and 3 sigma T. Now friends, improper axis of rotations. A molecule is said to be possessing an improper axis of rotation of order n if rotation about the axis by 360 divided by n followed by reflections in a plane perpendicular to the axis leaves molecules indistinguishable position. So if molecule has plane of symmetry sigma H perpendicular to the proper axis of rotation C2, C4 or C6, the axis naturally become the S2, S4, S6 respectively. There is a concept here C2, C4, C6 and S2 axis is equal to I. S2 axis is equivalent to I. If you have I, means S2 is there. Example, staggered ethane. You can see C6 indistinguishables. You have the horizontal plane. Now friend, inversions. If a point exists in center of molecule that identical atoms are found on either side at equal distance from it, the central point is called center of inversions. You can see this molecule in center Hg is there. So if you are in ethene, there is a I. In water and BF3 molecule, there is no I. In C2H4, there is a one I. Now I in some geometrical image like I present and in tetrahedral I absent. Identity E. If sequence of operations bring molecules back to its original configuration, the net operation is called identity operation. 2C2 rotation in H2O molecules equivalent to E. You can see. you have 1 and 2. After C2 rotation, 1 become 2 and 2 become 1. And then if you further do the C2 rotations, you are getting the same like 1. So this is the identity. In BF3, C3 and C3 is equal to E. C2, C2 is equal to E. C2, C2 is equal to E, or like that. Even sigma square D is easy. So E sigma and I generate one operations only because two successive I and sigma bring back the molecules to its original configurations. So sigma square become E, I square become. So you can see the sigma, after sigma, again identity. You can see in ethane 1 become 2 and 2 become 1, and then again it is look like 1. So sigma square is equal to E, I 2 times I is equal to E. So friend, but Cn Sn with n greater than 2 generate number of operations. Example, C3 generates C3 1 and C3 2. 2 times C3 and 1 times C3. If C same and same, then E. For example, in BF3, C3 3 is E. You can see. Then next, identity. E. Total symmetry of some molecules. The symmetry of molecules can be determined by listing all the elements present on it. You can see the water, E, C2, sigma V, YZ, sigma V, etc. In BF3, E, C3, 3C2, sigma H, 3 sigma D, and H3 is present. In ethene, E, 3C2, sigma H, sigma V, and sigma V prime, and sigma V double prime. In benzene, E, C6, C3, C2, 3C2, like that. So friends, take the precautions. Differentiating between sigma V and sigma D can be little tricky at first, but with the practice it should become clear. Both sigma V and sigma D are collinear with the principal rotation axis. In a molecule that has both sigma V and sigma D mirror plane, the sigma D plane bisect as many atoms possible. So top view, all 3 sigma V and all 3 sigma D shown. Side view, one of each type shown. You can see the sigma D and sigma V in case of benzene. So friend, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.